And so again, these become a very difficult type storm to be watching for in the sky and also on radar. In this perspective here, as we look at this on radar, we've got kind of two supercells that have merged together into one big blob. Over here on the left-hand side, the reflectivity data. An important element that you want to watch for when you're looking at the reflectivity data of a supercell storm is remember the hook shape echo and also the kidney bean shape. On the forward side of it is going to be that C-shaped pattern. That C-shaped pattern is the inflow notch where air is flowing into it. And so here you have an inflow notch. Air is flowing in that direction. Same thing back here. Here is an inflow notch. So just to the south of the inflow notch, that's the hook echo. This is the forward flying downdraft of the northern storm. Here's its hook echo back down here. Here's the inflow notch here, and kind of a combination of this storm's hook echo merges up with this storm's forward flying downdraft, and again, they're kind of wound together as one. It's hard to make out distinction between the two. And then south of the inflow notch, here's that southern storm's rear flying downdraft. But what's nice, though, is when you take a look at the velocity data, it can help pinpoint features for you quite nicely. Let me just go ahead and throw a couple circles on there to help make it even easier. Those represent the locations of the rotation centers, the mesocyclones. Notice where they're at in relationship to the inflow notches. So here you have a circulation center, and here you have a circulation center. What's really nice, too, is you can see the location of the rear flying downdraft shelf cloud quite easily. It's this boundary separating the red and green. So that's where the shelf cloud would be at in the sky. Notice this southern storm's rear flying downdraft is a little bit stronger, and in fact, overall, pretty broad for rear flying downdraft in comparison to the northern storm. But same story here too. Again, you could literally follow a cloud edge in the sky along this boundary, right along through this boundary here, right down through here, and continuing down through there. Not so easy to follow such a boundary when you're looking at the reflectivity data, but the velocity makes things a lot easier when you're looking for shelf clouds, when you're looking for wind speeds, when you're looking for rotation centers. And here we have the sky for that same storm. This one here, you can kind of make out the tornadic feature pretty well. Over here to the left-hand side, I really, to this day, I still don't know exactly where it's at, embedded within that. And again, the difficulties that you run into when you're dealing with high precipitation supercells. And so as a storm spotter out and about the county, you want to make sure you have access in all directions to get out of the path of the storm if you need to. And if you're at home, that you can get to your safe spot in a matter of minutes. The view from the storm, again off in the distance, in this case here, we're looking westbound. The storm is out to the southwest side, it's coming at us. And again, the boundaries that are in place there, the warm frontal boundary to the right, rear flank downdraft edge to the left, low pressure center in between, or that lowest cloud limit, that's where your wall cloud is at with your high precipitation supercell. From an idealized diagram perspective, classic on the left, heavy precipitation on the right. You can see this the simple difference. Rain wrapping on the rear flank downdraft side of the storm. In the sky, there's your different looks. Bright sky behind, rainfall behind in a high precipitation supercell. But again, in the use of that radar data, tying with what you're seeing in the sky really helps you a lot. Now, if you're just simply driving from home and you don't have a laptop with an air card sitting next to you, you're going to be in trouble. But some of these things that you see with regard to what to be watching for in the sky are important. And in fact, if you've been really good and paying attention to the weather before you even started traveling, you knew what to anticipate. As what I did when it was Memorial Weekend back in 2004, with the Indy 500 going on and a supercell storm heading towards Indianapolis. And I was called into work that day, and I had a decision to make. What part of that storm was I going to drive through? I chose the heavy rain portion up through the north side as opposed to the south side. And I think it was a good choice because had I driven through the south side, I very well could have driven into the path of that tornado because I was driving into work. I was listening to WIBC radio out of Indianapolis, and they were word by word passing word along where the tornado was at based on the reports that were coming from the storm spotters. So I felt good about my choice there. I got involved in some rain, a little bit of hail, but I missed the tornado in that particular case. Break time. Before we do, though, anybody have any questions over what I've covered here with regard to the supercell thunderstorms? Yes?
I sort of have a hard time putting
It's all dependent on where you're standing relative to the storm. Let me see if I can find an image here that will. It's all dependent on your position relative to the storm, where you're at, what winds you're going to experience. If you are standing anywhere in this zone here, and you're looking at the storm, you're going to have winds at your back flowing into the storm. That's the warm and moist inflow. If you happen to be at this location at this instant in time, what you will have experienced is the rear flank downdraft shelf cloud has passed overhead, and your winds have switched from a southeast to a westerly flow. If you were somewhere up in this area here, you're likely to have wind, and I'm not even sure what direction it'll actually be. If the storm was moving eastbound, you'd probably have winds out of the west blowing out of the storm in all various directions. So again, it's just dependent on where you're at in relation to the storm at that instant in time. Yes?
You said the best view of any tornado is in the path or the rain left.
Well, it depends on where you want to be and how close you want to be. The rain wrapped storm is a difficult one. You're going to have a hard time seeing it because it's wrapped up by rainfall. No matter where it's at and where you're at in relationship to it. But in the case of the classic supercell, which still is a fair share of them, a position somewhere down here, I mean, look at where you're standing. In this position here, you're not getting rained on. You've got a great view of the sky off to your north and northwest, so you've got this perfect picture of this low-hanging cloud from which the tornado is going to drop out of. If you're positioned over here and it's moving left to right, what's going to happen? You're going to have all this rain falling on you, and you're not going to see a thing. If you're positioned up here to the north and looking down through that core of that storm, there's no way. You look out there, the sky looks black to your south, but you're not going to see anything. And so that's, again, why as a storm spotter and a mobile storm spotter, they always try to position themselves somewhere in the inflow here because they're going to be in a good position to be able to see the things they want to see. If you're watching from home, you have no choice. It's all in how that storm passes across your neighborhood. If it's passing across just to your north, you might be in a great position to see what you want to see. If it's coming overhead or to your south, you won't. Okay. Well, let's just go ahead and take a short break.
Everybody
here.
needs to sign up on the National Weather Service clipboards, and the ham operators have a folder.
Okay, so ham operators, you got a folder to sign. The rest of you, if you didn't get a chance to sign that clipboard beforehand, it's back at the table. So again, we'll meet back at 5, and we'll continue on with tornadoes.